Hello, so today we're going to talk about common logarithms and the change of base formula. And so common log equals the log of base 10. Okay, so if we ever write a log like this, you can just assume that we mean 10 down there, right? So these two things are equivalent. So sometimes shorthanded, we write this and we mean this, okay? And why base 10? Because we're a base 10 number system, as you know. So, an example, evaluate log base 10 of 100 equals x. Well, so that just means 10 to the x equals 100, so x equals 2, because 10 squared equals 100. So what about this one? Log base 10 of 10, the square root of 10 equals x. Well, 10 to the x equals the square root of 10, which means 10 to the x equals 10 to the 1 half, and x equals 1 half. And so how about the log base 10 of x equals 2. Well, 10 squared equals x, so 100 equals x. All right, and so we could have written those without any of those 10s as the base, and those would be common logs. That's what the log button, the very basic log button on your calculator does. All right, so how about if I give you 3 to the x equals 9? Well, we know what the answer is, right? It's 2. And what if I give you 5 to the x equals 125? Well, again, you should remember what this one is. X equals 3. Well, what about 7 to the x equals 17? Right? No, not going to happen. So, we can use common logs to solve exponential equations. All right? And this is why logs are so awesome and so handy and so important. If I give you 2 to the x equals 9, well, that's the original problem. And if I take the log of both sides, notice these are just log base 10. So I'm just going to write log. If I take the log of both sides, and I've done the same thing to both sides, so that's valid, I can take the log of both sides. What happens is I can apply the log properties, right? Now I can use the power property and get that x down here. And that means I can just solve like normal now. I can divide both sides by the log of 2 and divide the log of 9 by the log of 2 and just find out that x equals 3.170. All right, and I'd use my calculator for these two things here. And so another one, 3x equals 15 again. I don't know. So I can take the log of both sides, and that's called the property of equality for log functions. And I can use the power property again, and I bring my x down to the front as a coefficient, and now I can just divide by this log of 3 on both sides. And just be careful, right? You can't simplify these, right? You got to think about this as a like parentheses around it. You got to evaluate the log of 9, and then divide it by whatever log of 3 was, and here's the solution we get. And again, you do this in your calculator. You push the log, then 9, and then divide it by log 3. Right? And so one more example, 6 to the x equals 42. Right? And so we take the log of both sides, and again, we use the power property to get this exponent down in front, and then we divide both sides by 6. All right? And so now we have x equals whatever this evaluated to, and it was 2.086. All right, so something a little new. Oh, one more example, sorry. What if we have 2 to the x plus 2 equals 10? Well, it's the same exact thing. All right, take the log of both sides, and then our exponent, though, is x plus 2. And notice I put parentheses around it because it's x plus 2 times this, right? It's not 2 times this or anything like that, right? We have to have parentheses around this. And so we can divide both sides by log 2. Oh, that should say log 2 right here, right? That should say 2 right here, right? Because we're dividing by log 2. Right? And that means we have x plus 2 equals 3.322. And we just have one small thing left to do. Subtract both sides by 2, and we get x equals 1.322. And you could plug that in right here, right? And you get very, very, very close, if not, if your calculator doesn't actually round it all the way to 10. All right, so one more like that. 11 to the x minus 3 equals 5 to the x. Uh-oh. So that's our original problem. We take the log of both sides like we've been doing. And what happens? Well, we use the power property to bring our exponents down. So we have this equation right here, right? And so, what should we do now? Well, we can start by solving for x, right? So we can divide both sides by log 11, right? And again, this should say log 11 right here. I'll try and fix that after this video, but if not, this should say log 2 and this should say log 11, right? And so what happens here? Well, we evaluate some stuff, right? We evaluate log 5 divided by log 11. So we have x minus 3 equals x times this quotient, okay? And so now we're going to have to just subtract, okay? So we subtract x from both sides. So I subtracted x from this side, and I subtracted x from this side because I have some amount of x. So I end up with the negative quantity of x equals a negative 3. And so now I just divide both sides by this negative 0.329, and I got x equals 9.124. Right? This is all about the process, guys and girls. How do I do it? Use your calculator to help evaluate some of this. Use your calculator to do this, but knowing what steps to take. And it's a really good idea to at least write all this out. You don't have to write all this out necessarily, but writing out each of these steps will make sure that you get it right every time. So here we come to a change of base formula. Now some newer calculators actually have a log base button, so you can actually say what base it is, but in the past, calculators only had common log buttons, base 10. And so we can use this base 10 button to convert and calculate using other bases, okay? So the change of base formula says that if we need to get log of base a of n, we can use the same log here, and this b should essentially be 10. This is kind of complicated. Write it down, but let's look at examples, okay? So if I wanted to evaluate log base 8 of 15 and on my calculator, or I needed to write it in terms of common logs, then we do the following, all right? We say that that's our original problem, and what we can say is that just like this, our n and our a, we can rewrite it as log 15 divided by log 8. So this is the common log. It has a base of 10 and a base of 10, and this is the log button on your calculators. So if you ever had to do this and you only had regular log buttons, you can evaluate this, and these two things are equal. Like I said, some new calculators have the ability to actually evaluate this, but in the past you couldn't. So this is how you would evaluate this, right? Okay, so our exponent goes here and our base goes on the bottom, right?